Right, good day guys. So now we have this question on, we are doing 5 quick question on physics, Jamb physics. So the first question we have here is on specific capacity or its capacity, but its capacity and specific capacity, they are quite different from each other. So they are quite different. So I'm going to be telling you in this video how they are different from each other. Now let's look at this question. They said a block of aluminium of mass m is heated electrically by 25 watts heater. They now said if the temperature rises by 10 degrees C. Now you should know this, that 25 watts, it represents what? Our power, which is what? 25 watts. So they now say the temperature rises by 10 degrees C. Whenever you have temperature rises is delta theta. Or if they say rise in temperature, it represents what? Delta theta. Then they give you what? 5 minutes. If you look at this is your time. And the SI unit for time is seconds. So it means you need to convert your time to seconds, which is what? 5 times 60. So that will be what? 300 seconds. So that's your time. Now, what's the formula for? They now say you should calculate your heat capacity of the aluminium. You should know this, that heat energy is equals to mc delta theta. That is the mass, the specific heat capacity, and the rise in temperature. Now, what is the specific heat capacity? So this C represents the specific heat capacity. So that's your specific heat capacity. So it is measured in joule per kilogram per Kelvin. Now, what's our m? So that's the mass. What's our delta theta? So that's our rise in temperature, or temperature rise. So you know that it can be measured in Kelvin or degrees C. And mind you, you don't need to convert to Kelvin. If your temperature is in Kelvin, you leave it like that. If your degrees is in Kelvin, is in degrees C, just leave it like that. Unlike in gas law that we need to convert to Kelvin, but here just leave it the way it is. So now they now ask us to find heat capacity, not specific heat capacity. Now what is heat capacity? So heat capacity, let us represent it by Cp. Is the what? Is the mass, is the combination of mass and specific heat capacity. I hope you understand. Now let's represent this mc with its capacity. So it will now be H is equals to Cp delta theta. I hope you understand. So that's the formula now. That is Cp times delta theta. Now, you should know that the heat energy is also equals to the power times time. Now, for us to now get the Cp, it means we are going to equate this Cp times T to this what? Cp delta theta. So it's now going to be what? Power times time is equals to Cp delta theta. Now let's make this subject of formula. We are now going to be having Cp is equals to P times T over delta of theta. Now what's our P? So let's bring it here. Our P is what? 25. They've given us our time. We got it 300. Our delta of theta, that is 10. So let's find it. So that will be what? So our answer is what? 750 joule per Kelvin. Please take note, the unit of Cp is what? Joule per Kelvin. While the unit of specific heat capacity is what? Joule per kilogram per Kelvin. So let's go to the next question. So the next question states, what is the energy with which an incident light? So this question is on area of those atomic physics, those thermionic emission, all those topics there. So they're asking us to find the energy with which an incident light of wavelengths. So let's write our parameters out. It is good to write our parameters out so that you can know it. So the first thing we are given is the what? Wavelength, which is 10 raised to power minus 7 meter. That's the first thing we are given. They now said falls on a metal and electrons are emitted. So they now said they're giving us C. What is the meaning of this C? So the C is representing the speed of light. So 3.0 times 10 raised to power 8 meter per seconds. So that's our E. Now they now said H. This H is what? Is the Planck's constant. So 6.63 times 10 raised to power minus 34 joule seconds. They now say we should find the energy with which an incident light in of wavelength 10 raised to power minus 7. So they ask us to find the energy. So the formula for a question like this is hc over lambda. Each was hc over lambda. So let's do it. We're now going to be having 6.63 times 10 raised to power minus 34 times the speed of light 3.0 times 10 raised to power 8 over what's our wavelength 10 raised to power minus 7. So now let's quickly. So we're now going to be having 1.989 times 10 raised to power minus 18 joule. Minus 18 joule. So that will be what? Approximately 1.99 times 10 raised to power minus 18. So automatically looking at this place, our answer is what? Option A. So I hope you understand. So that's how to do questions like this. So let's go to the next question. So the next question states thus. This question is from elasticity. What is elasticity? It states that provided the elastic limit is not exceeded, he said the force is directly proportional to the extension of an elastic material is directly proportional to the extension. So provided the elastic limit is not exceeded, so the extension of an elastic material is directly proportional to the applied force. So that the statement is represented by F varies E. So we are now going to find F is equals to what? Ke. Now what is the meaning of this K? This K is the stiffness. So that's not what we are really doing now, or it's also called the force constant. I just want to give you a brief overview. Now here we now have what we call the Young modulus. This Hooke's law also states that we can also get it that stress is varies directly proportional to the strain. Now in mathematics, when we want to remove the sign of proportionality, we are going to input a constant beside it. So the constant is K times strain. Now let's divide both sides by strain. So our K now will be what? Stress over strain. Now this K, we now represent it with what? Young modulus, which is this. Yes, represented by the what? Young modulus. Now this is what is now what? Stress over strain. Now what is stress and what is strain? The stress is equals to force. Let me write it in some way that you can quickly see. So stress is equals to force over area. While strain is equals to the extension over length. So that's the strain. I hope you understand. So that's it. Now they now ask us to find, in this question they ask us to find the tensile strain. They ask us to find the what? This tensile strain. That's what they ask us to find. They ask us to find the what? The tensile strain. So that's what they're asking us to find. So stress, they now say we should find tensile stress. Tensile stress is also stress. So stress is stress. So what we are using is stress. They now give us force. What's the force they give us? They give us force to be 500 Newton. And they also give us cross-sectional area. So that is 0.2 meter square. So it's 0.2 meter square. So that's our cross-sectional area. And you know that stress is force over area. So we are just going to input it and then we get our answer. So 500 over 0.2. So that's our stress. So stress is just like pressure. So both of them they have the same formula and the same unit. So just like they have some little difference. So 500 divided by 0.2. So that is 2500. Now if you want to represent 2500 in standard form, how will you do that? So let's say we have 0.0. You know that's 2500. 2500 is same thing as 2500.0. So let's leave it one by one. 1, 2, 3. So that will be what? 2.5 times 10 raised to power. So times 10 raised to power 3. Times 10 raised to power 3 Newton per meter square. So that's the unit for what? Stress. So that's our answer. So option C is our right answer. So let's go to the next question. So now this next question state does. So this question is from electrolysis. So how do I know the topic we are? You know that this is not my first time doing this questions like this. So now calculate the mass of, this question is from electrolysis, first law of electrolysis. So they now said calculate the mass of the copper deposited during electrolysis when a current of 4 ampere passes through a copper salt for 2 hours. They now say the ECE here represents the electrochemical equivalent of copper, so which is 3.3 times 10 raised to power minus 7 kilogram per coulomb. Now, what's the first law of electrolysis tell us? It tells us that the mass is directly proportional to the quantity of charge. Now, in mathematics, I told you earlier that when you want to remove the sign of proportionality, you will put K. But instead of us putting K, we are going to put Z instead. Now, what is Q? Q is the product of current to time. So let's bring it to this. So it's going to be F equals to Z I T. And what is the I? The I is the current, and the T is the time, and the Z is the electrochemical equivalent. That is the ECE equivalent. That is the ECE. Now, if you look at the question, they've given us they asked us to find the mass. They now said when the electrolysis, when a current of 4 ampere, so they're giving us a current of what? 4 ampere. They now give us a time of 2 hours. And you know that 2 hours is not the SI unit of, hours is not the SI unit for time. So we need to convert these hours to seconds. So how do we do that? You will multiply it by 3600. When you are converting from hour to seconds, you will be multiplying by 3600. So that will be what? How will I write it? So it's 7200 seconds. So that's our what? That's our time. Now, the formula we are using is M is equal to ZIT. They've given us Z, which is what? 3.3 times 10 raised to power minus 7. So what is our M now? So our M will be 3.3. We will use the formula 3.3 times 10 raised to power minus 7 times, what's our high? So our high is 4. What's our T? That is 7200. So let's multiply everything. So you are now going to be having, when we multiply we are going to be having 95,000. Now, how do you think we are going to bring the thing together? So it's now going to be what? 10 raised to power minus 7 now to be what? Normally, let's express this in standard form. It will be 9, 1, 2, 3, 4. So that will be 9.5 times 10 raised to power 4 times 10 raised to power minus 7. So how do you now do it now? So you add this together. It will now be 4 minus 7. So that will be 9.5 times 10. You take a single base. That will be what? Minus 3. So our answer here is clearly stated. And what's the unit for mass? Kilogram. So that will be 9.5 times 10 raised to power 7 minus 3. Kilo. So that's our answer. So our option is option A. Let's go to the next question. So now the next question states, this question is based on how the electric companies they calculate the way we is the way they calculate how they make money. You will look at your bill. This is how they calculate the number of money they bring to us. So this question is based on it. If you look at it, there is naira there. So naira. So this is how the IBDC or the NEPA, they calculate the amount of money they give us. Now they now said, now the money they give us is a unit. A unit, whenever they say a unit, like this place, they say the unit is 1500. This a unit is measured in what? 1 kilowatt hour. I hope you understand. So that's a unit. They now said a unit is 5 naira. So it means 1 kilowatt hour is what? 5 naira. Please don't forget, a unit is what? Kilowatt hour. Now they now said a house has a 10, 40 watts and 500 watts. So it means we are going to look for kilowatt hour. After we get a kilowatt hour, we will now multiply it by 5 naira. We will now look for the number of money it will give us. So 1 kilowatt hour, how do we get kilowatt hours? From these parameters they give us. They give us 10, 40 watts and they give us 500 watts. So it means this is the way we are going to do it. Then we multiply it by this time. So now this we wait. They now say 10, 40 watts. So 10, 40 watts will be what? 10 times 40 plus, we will now add it to this one. I hope you understand what I'm doing. So it will now be what? 5 times 100. I hope you can understand. So it will now be 400. You know that both of them are in watts, plus 500. Now going to give us 900 watts. I hope you understand. So we've gotten watts out of, so it means we still need hour, and we need to convert this watt to kilowatts. So to do that, we divide by 1000. So that will be what? 0.9 kilowatts. So now we've gotten 0 kilowatts. So we need to get what? Kilowatt hour. So we multiply this hour by this. So it's now going to be what? Is 0.9 kilowatts times 10. So that will be what? That will be 9 kilowatt hour. Now we now bring it to this place. So it will now be 9 kilowatt hour to x. I hope you understand. So we are comparing. So you now cross multiply. So this will be what? X times 1 is equals to 5 times 9. So our x now will be what? 45 kilowatt hour. So instead of kilowatt hour, you know that this place is naira. This place also will be what? Naira. So and our x is naira. So it will now be what? 45 naira. So it means 45 naira is the cost of a unit. So for 10 hours. So it will be what? 45 naira. So I hope you understand the way we do it. You must first get kilowatt hour. So that's for this video. Bye. So it's very, very simple. Bye.